Hello everyone. My name is Venu. I have more than 15 years of experience in IT industry. Let's get into it. So as we're talking about what is the agenda for this webinar, as you can see. So we're going to understand about what is machine learning, what are the different types of machine learning techniques we have. And we're also going to introduce about unsupervised learning, where the clustering techniques that we're talking about are part of unsupervised learning. So that's the reason we are going to understand about what is unsupervised learning, and then we'll also be talking about what is unsupervised learning, what is clustering techniques, and why clustering techniques are required, and what are the different or topmost 5 clustering algorithms that are available. And we'll also see an example of how do we apply the clustering technique with an example. Okay, so that's what we're going to do. So let's move on. So what is machine learning? So what is actually machine learning is all about? As the name says, machine learning, where as a human as a human, how do we know that these are the decisions that we need to take? Say, for example, when I'm trying to drive a vehicle, so how do I know that this is how I need to drive the vehicle? Did anyone has mentioned anything to me? No, right? Every time, is there anyone who is going to sit with me and then who is going to say like, okay, this is how you need to drive the vehicle? No, right? I learned it from some driving teacher. From their experience, I have learned it, and after learning it, as a human brain, I'll be able to take my own decisions on how to drive and on how to what are the actions that I'm supposed to take. Right? That's what a human. That's why human brain is something which has become more powerful, that is now dominating everywhere. Whereas if you take a machine is something that will never have such intelligence to take decisions on its own. When you take any machine, a machine has to be given with an instruction, a clear instruction. Say for example, you take a machine and you ask a machine to go and bring let's say for example, I want a machine to be to pick a pen and then hand over it to me. I should give an explicit command stating that, hey, can you pick that pen on the table, and I want you to hand it over to me. If there is a different object, for example, there is one more object that is present on my table called a water bottle, for example. So I need to give a different instruction to a machine, then only a machine can perform. But a machine itself cannot take a decision without you giving a command. So what is machine learning? A machine learning is something that enabling an additional capability to a machine. A machine learning is something that we will be enabling an additional capability to a machine by providing more amount of historical data as an input, that where your machine will go through all such a huge volume of data, with which the machine will become self-intelligent, that it itself can start taking the decisions. Because when you take any applications that people would have seen, say for example, based on ATM machine, you take your mobile app. They were not self-aware programs. They were something where they'll be following some instruction which is given by some developer. Whereas if you take an example of the other algorithm that you are able to see, the face recognition, the image recognition, so they were all algorithms. Those algorithms will automated in a way that whatever the instruction that you give, they will take the data, they will automatically will work based on the data that you have provided, right? So these algorithms are something which are built using some of the deep learning techniques to process on top of unstructured data. So that's what machine learning is all about. So making an additional capability that will give that can make a machine itself to take a decision. So now what is machine learning? So based on the type of data, based on the type of input, and based on the type of output that we wanted to produce, that we can produce, these machine learning algorithms are primarily categorized into 3 different groups. There are a number of algorithms based on the type of data input and output that we want to produce. Machine learning algorithms are primarily divided to 3 categories. One is supervised learning, the second one is unsupervised learning, and then third one is reinforcement learning. So what is supervised learning? When we have some data, where when we say some data, means that when we have the historical data, where the historical data, we have got complete clarity on the historical data, which means what is the historical data, what is every column. Okay, there is a column called gender, there is a column called age, there is a column called address of a person. We have complete clarity on the data. So that data is what we call it as the algorithms which we apply on top of such data, where we also have output column present in the historical data, is what we call as supervised learning algorithms. Which means, let's take an example of sales of an organization. We have the historical data of sales of an organization, where in the sales will be depending on some time series. You have some time series data saying that, okay, in January 2020 you got this much of sales, in February 2020 you got this much of sales. Likewise, you have some historical data which contains all the sales information, which means you have input column, you have output column. So the algorithms which are used on top of such data to predict the future sales is what we call it as supervised learning algorithms. I'm just taking an example. So now, what is unsupervised learning algorithm? When we have some data, you may or may not have clarity on the data, and you only have independent variables present in the data, is what we call it as unsupervised learning algorithms. So which means, what do I mean? You may or may not have clarity on the data. Let's say, for example, you're extracting some sensor information. There are a number of manufacturing organizations which are manufacturing so many things. Every sensor might extract so much of data based on the way how they are manufacturing the components. So they might be extracting a lot of data. You may not have clarity on the data because that data is something which is produced by machines. And you don't have output column. They'll just give some independent variables or input column. So the algorithms which are used on top of such data is what we call unsupervised learning algorithms. But when it comes to the third component, like reinforcement learning algorithm, as you could see, in supervised learning, you have input columns and also output columns. In unsupervised learning, you have only input columns present. There is no output column present. There is only input columns which are present in the historical data. The algorithms that we use on top of such data is what we call unsupervised learning algorithm. What is a reinforcement learning algorithm? We don't even have input data. It's very simple, right? So, supervised learning, you will have input columns and output columns. In unsupervised learning, only input columns. In reinforcement learning, there is no historical data. So then without data, there is nothing called data science, right? Then how it will work? Which means it never happens like that. What reinforcement learning algorithms will do, which means first you will build a machine. Once you start training this machine, while going through a training process, while going through the training process on live, it's going to extract the historical data it requires, and it itself is going to train on top of the data that you're going to train. It itself will start extracting the data. So the best example is about where humanless cars. The best example to talk about reinforcement learning is humanless cars, where you can see that a lot of organizations are now coming up with driverless cars. You don't need to drive the vehicle itself will start driving. Such algorithms are built using reinforcement learning algorithms. They are the primary three categories of machine learning that we have: supervised learning, unsupervised learning, and reinforcement learning. So now we'll jump into what is unsupervised learning. As I said, the unsupervised learning algorithms are something that we will use when we have some data where we may or may not have clarity on the data. In such cases, or especially we don't have output column present, is what we call it as unsupervised learning algorithms. So within unsupervised learning algorithms, we cannot just like that say we'll be able to make without output. We cannot say like we'll be generate some output, right? We need some output that needs to be generated. When we have some input, we need some output that needs to be generated. So there might be some unhidden patterns which might present in the data. As you can see, you have some data which you don't know. Okay, how can I segregate this on, and how can I segregate the n number of observations that we have? There are different types of input that we got. We wanted to use, there is no output column which is present. We don't know how to categorize them. Based on the patterns which are present within the data itself, we want to convert them into some groups. That's what I'm trying to talk about, something called grouping techniques, which means I want to identify the similar patterns. Whatever the ones which are looking similar, I want to classify them automatically. Yeah, you're not going to do that. A machine, an algorithm is going to build a model. That model is going to do this activity. When you have millions of observations, where you may not be able to segregate all such things in a way that I will be able to group, saying that okay, these are the observations which belong to one criteria, or these are the observations which belong to one criteria, which using these unsupervised learning algorithms will be able to do such activities. That's what we typically call it as clustering technique. So what is a clustering technique? Clustering technique is something that we will use it for grouping purpose. So especially there is a very easy way to understand what is clustering technique. You would have seen such a while we are going through an COVID-19 situation, the government has came up with creating some containment zones, as all of you must be knowing. So how, on what criteria government has taken that, okay, which area is supposed to be a containment zone, or which area is supposed to be applied with some restrictions, or which areas can be considered as normal, on what criteria that they have created. So that's what using clustering technique, which means the governments, or when I say government, means that the people who will be taking the final decision in such criteria, either prime minister, either the chief ministers of that particular state will be taking decisions whether to go for a lockdown, whether to not to go for lockdown, or which areas has to be considered as containment zones or non-containment zones. So those high level decisions are something which will be taken based on the clustering technique output which is generated by these algorithms, based on a number of inputs. Okay, what is the population in a particular area, how many number of people are affected, how many number of hospitals which are present, how many number of people who are been recovered. So likewise, based on these multiple criteria, people will do some clustering technique on top of the data, and according to that, people will be segregated, or the areas will be segregated, so that saying that, okay, these are the observations which belong to one cluster, these are the observations which belong to one cluster, like that, so that people can cluster them, which can make organizations to take decisions on a very high level. Okay, that's what is our clustering technique, which clustering technique output will contain the different groups. It itself will group the different components based on whatever the number of clusters that you want to generate. That may not give the direct output. On top of the generated output, people will be taking business related decisions. That's what is all about clustering techniques. Okay, so now what we will do, let's take an example of within clustering techniques, what are the different types of clustering techniques we have. So what are the different types of clustering that we have? So there are multiple types of ways based on the type of output that we want to produce. There are multiple different types of clustering techniques we have, but out of which let's try to understand about what are the very famous and most widely used clustering technique algorithm, out of which we have something called k-means clustering algorithm is one of the very famous and most widely used. More than 90% of the people will end up with using k-means clustering algorithm, which is very famous in clustering techniques, right? Which is very famous in clustering techniques. So what are these clustering techniques? As I said, how this clustering technique will work. So k-means clustering is nothing but, always remember one thing, if any one of you are going to work in machine learning or anywhere, wherever you see a notation called k, by default k is nothing but you are supposed to, as a user, you are supposed to provide what is the input of k, which means wherever you see, there are multiple techniques that we have in machine learning, like k-means clustering technique, k nearest neighbor is one of the algorithm, k-fold cross validation. Likewise, wherever you see a notation called k, what does a k means? It's an input that you are supposed to provide. Always remember this. It's an input that you are supposed to provide to your algorithm. Your algorithm cannot identify that k value. Of course, everything else will be taken care by your algorithm. But whenever you see k, which means in k-means clustering, what is the meaning of k-means clustering? How many number of clusters that you want to provide? That is something that you have to input it to your algorithm. That is something that you have to input to your algorithm, right? Here, the meaning of k is how many clusters that you want to generate. So how many clusters that you want to generate? Okay, when you have 1,000 observations which are present, when you have 1,000 input records which are present in your historical data, how many number of clusters that you want to produce? Do you want to go for one cluster? Obviously, one cluster means that the entire data set will be considered as is. Do you want to create 2 clusters out of the data? Do you want to create 3 clusters out of the data, 4 clusters, 5 clusters, or 10 clusters? So how this can be done? There are multiple steps that are involved in generating k-means clustering algorithm. So you can see, choose the number of clusters. This is what is nothing but your first step. It means you need to decide what is your k is nothing but number of clusters that you want to produce. And then there is an initialization of centroids will happen as a one-time activity, right? So there is an initialization of centroids which will be declared, that will be used as your initial step for your machine, and then assign the clusters, move the centroids, and optimization, and then converge all the clusters into one component. Yes, I know it will be very difficult to understand by looking at this thing. So let me show you a very simple example how exactly it will be done. Maybe let me take a simple diagram for you to show how exactly that's going to work. Okay, so let's say for example, I'm going to take some historical data just to explain you on how exactly the k-means clustering algorithm will work. So what is that it is written in the first step? What is that it is written in the first step? So the choose number of clusters. Choose number of clusters. Now which means, say for example, we need to take some historical data. I'm considering some historical data here. Let's assume this is the historical data. Let's assume this is the historical data that we have. So as you can see, there are multiple historical data points. So as you can see, the first step, choose number of clusters, which means let's assume to make this thing simple, I'm going to choose that we want to have 2 clusters generated. Okay, so this is, which means we want to have 2 clusters created. So because my number of clusters that I want to generate is 2, I'm going to consider that there are 2 centroids which are present. This is my first step. How this algorithm will do? How algorithm will come with the number of clusters? So this is how it will happen. So first step is to choose the number of centroid and then initialize your centroid. That's the second step. So now what is the third step? Let's assume this is observation number 1. This is our data point 1. So now what is the next step? We will take the distance from every observation to every centroid and every observation to every centroid, which means now tell me which observation, for this observation number 1, which centroid is more closer? Is the green color centroid is more closer or the red color centroid is more closer for this? Centroid means that data points, the one which I have highlighted, that's what we call a centroid, data points. We have chosen 2 centroids only because that is as a user you are supposed to input what's supposed to be your k. What's supposed to be your k value, that's what I said. You need to know what is your k is nothing but how many number of clusters that you want to provide. Usually your business users are going to provide that. In case if you are going to work in this kind of algorithms, they will provide that. Or else there are some methods available like elbow method or other things. We will talk about that. Now this observation is more closer to red color. So now what happens? What is the next step? The algorithm will assign this particular observation 1 as a red color for now, as considering that this belongs to red color. Likewise for the second observation, when the second observation appears, what is the distance from the second observation to both the centroids? Now which one is more closer? I see green color is more closer. So now I'll mark this as green color. If the distance is same equal, so then the algorithm will force any of the observation to get into any of the centroid. So number of clusters, number of centroid that you will choose based on the k value, as I said. Now you're going to likewise you will repeat the same process, and whatever the observation which is more closer to whatever the centroid it is, you will mark them as with their so-called mark like this. Now you are going to initially mark them as observations into either into green color, either into red color. So now these observations are now considered as green color observations, and these observations are now considered as red color observations. This is step number 1. What is the step number 2? Step number 2 is segregate all these red color observations and take the average value of x and y coordinates, and repeat the same process for calculating average coordinates of x and y coordinates for the green color observations. Take the average of all these observations, calculate average, and take all these observations, take the average. You'll end up with getting a new centroid positions called xy, which means now you ended up with getting a new centroids. In the initial step that we have taken random centroid, now you got the centroids that you can use based on the previous iteration. Now you ended up with getting a new centroids. You repeat the same process again you repeat the same process. Take the distance from every observation to every centroid and assign the observation based on the nearest distance, and continue to mark every observation either into red color or either green color or whatever it is, and you repeat the process until you will be able to see there will be no change applicable for your clusters. You repeat the process, which means in every step you might end up with changing your centroid. Every step will continue to change your centroid. Now the centroid might become like this, then later your centroid will become like this. Likewise your centroids will be keep on moving. Initially you are taken it like this, but it might continue to move like this. Somewhere it will be fixed, and after that there will be no change that you will notice if you are repeating the same process. At this particular stage, whatever the observations which are marked into, which are grouped into green color, you will say like these are the green color observations. Whatever the observations which are marked into red color, you will mark them as okay, these are the observations which belong to red color. These are the observations which belong to red color. Likewise, you will segregate all these observations either into red color or green color. Right? So that's how we can generate these clustering technique. That's how the k-means clustering algorithm will generate these algorithms output of using this algorithm. Okay, so that's how k-means clustering algorithm will work. Okay, so now likewise there are multiple algorithms that we have. So like when we talk about machine learning, so there are multiple types of algorithms that we have. So like how we have the how does the k value will occur, as you can see on the ppts which are also mentioned. So you're going to choose some randomly generated k value, and you will be choosing the number of k's over here, and you can see that it will assign them based on the number of this easy most nearest distances, and according to that you will change your centroids. Once you change your centroids, you will repeat the same process until you are able to change that your centroids don't move further, and then once it has been finalized, you will select this is the final centroid and final cluster output that we can generate out of this, right? So likewise, we also have different types of clustering technique, and the second type of clustering technique that we have is fuzzy or C-means clustering. So what is fuzzy or C-means clustering? The output will remain same. So C-means clustering means that there are places that one or two observations can belong to one or two different clusters, right? One or two different clusters, which means usually the primary difference between your C-means and K-means clustering technique is, in case if there are any observations which are having equal amount of distance, usually in K-means clustering what we will do, we will force this observation to be part of any of the cluster. But in C-means clustering, based on the distance that we see, there are chances that an observation can go to or can belong to one or two clusters. So it purely depends on the business use case, who is going to decide to either to go for K-means clustering or C-means clustering based on the business use case, based on our business outcome. So if people are going to decide whether to go for C-means clustering or K-means clustering. So there are a number of observations which might, it's not mandatory, which might can belong to one or more clusters that can happen. So the third is agglomerated clustering, so which is the third type of clustering technique that we have. Okay, so which is also one of the clustering technique that we have. Okay, so now which can also be used here. Okay, so now what is this agglomerative clustering? So this is what we also call it as hierarchical clustering. So in times you'll also call them as hierarchical clustering. These clustering techniques are built using H clustering. In short, we call it as H clustering, and also people will also call it as hierarchical clustering technique. So what are this? So based on the type of algorithm, they will try to, there is a mathematical expressions which are involved in it, but considering that the limited time that we have, I'm not going to take you through all the in detailed depth of it. So considering the way how the data points have been segregated, it will build a kind of dendrogram. So on top of this dendrogram, your observations can be classified here like this, as you could see on the screen. Is K-means clustering sensitive to outlier? You need to understand one thing. When we are talking about unsupervised learning algorithms, as I said, you may or may not have clarity on the data, which means your assumption is that at the least level you don't have clarity on the data. Then if you don't, when you don't have clarity on the data, how can you say this is an outlier or this is not an outlier? When you have clarity on the data, especially when you're working on supervised learning algorithms, you can, but you don't have output column also. How you will be able to evaluate how the so called output column can be evaluated, because this is not been classified properly, this is not been clustered properly based on the historical data, because there is no output column. So those type of concepts are something which you don't need to worry about when you are working on unsupervised learning. They will be constrained when you are working on supervised learning algorithms. And of course, in case if you see that there are outliers which are present, obviously it will be considered as one of the clustering any of the cluster it belongs to the data. But anyhow, that's the characteristic of the data. You don't need to, you won't be taking care, because you might be killing the actual original values which are present in the data, but you cannot expect that outlier can be recognized out for all the cases that you have in unsupervised learning. So the next type of clustering technique that we have is division clustering. So what is this division clustering? As the division clustering is also creates the data in a form of dendrogram, but the difference is you can see that it starts with all data points in one cluster, splits the root into child recursively based on the dendrogram, and stops when there is a singleton clusters which are created, which means that for every cluster there will be one observation which belongs to. So likewise, the clustering technique will work. Now there is one more technique that we have in terms of building a clustering technique. That's what we call the mean shift clustering. So what we will do, we'll take an average of every cluster that we have. What we will do, we'll end up with reducing their means into a single density of items, and then we'll continue to repeat the process to see to that which observations mean will belong to the same cluster, and according to that we'll continue to identify which observation will belong to a cluster, a particular cluster. So likewise, we can apply different types of clustering technique that can help us to cluster the data which is part of unsupervised learning, right? So now let's jump into something called a small hands-on. Okay, let's take a small Python example, and we will see how do we build that particular clustering technique on top of the data using one of the simple data that we have. Jupyter Notebook. Let me open how we can use scikit-learn using one of the example. So meanwhile, let me show you some of the data set also. Let me show you a data set that I'm going to use as well. So what I'm going to do is I'm going to take this movie metadata information. Let me open this data set. I'm going to take this example of movie metadata information where this data set has got a number of observations which are present. Okay, let me open this. Okay, you can see that there are a number of movies related information. As you can see, the movie names. So Avatar, Pirates of the Caribbean, Spectre, The Dark Knight, Star Wars, etc., etc., John Carter, Spider-Man 3, Tangled, or etc., etc. We have a lot of movies. And about every movie, we got a lot of information which is present, like who is the director, who is the actor, what are the director Facebook likes, what are the actor Facebook likes. Likewise, we got a lot of information which is present as part of these particular every observation. So now what we will do, we will try to cluster these data points. You can see a lot of observations which are given. What is the gross of the movie? What is the number of reviewers? What is the IMDb rating? What is the so and so called IMDb score? What is the movie span? What is the gross? What is the budget and everything? So now what I'll be doing, I'll be reading this data set using one of the pandas library that we have. Okay, so I'll be reading this data set. Let me open the Jupyter Notebook. I'll be using something called pandas. As you can see, read.pandas.csv. I'll be reading this data set where you can see that this is the data set that I am able to read. I got a number of observations that are present. I can see that director Facebook likes and actor 3 Facebook likes. So now what is that I want to do is, instead of building this clustering technique on top of every observation, so what I will do is I will take these columns called number of Facebook likes on director and number of actor Facebook likes versus director Facebook likes. So where I can see that if I want to select a director Facebook likes alone, I'll be able to choose this director Facebook likes alone. You can see for every movie you got the number of director Facebook likes which are present. So if there are more number of Facebook likes, what does it mean? The director is famous person, correct? Or either if there are more number of famous Facebook likes that the actor has got, which means that the person is or the actor is very famous person. So that's what you can understand. So now you can see that I'll try to extract these independent components that we're talking about. I will extract all the records in all the director Facebook likes versus actor Facebook likes, where I'm just going to form an object called new data by applying some iLocation as a filter. iLocations, ILOC stands for index location, where I can filter out what are the records that I wanted to, what are the columns that I wanted to, using this iLocation function. Now I got all the so and so called number of director Facebook likes versus actor Facebook likes which are present as part of this. Okay, so this has been loaded into an object called new data. So now what is that I'll be doing? After that, I'm importing something called sklearn k-means cluster. So this algorithm is available as part of this scikit-learn algorithm. Whatever the number of steps that we have discussed, you're not supposed to execute all these steps manually. And of course, if you want, you can also write such a program as well. But what is that we'll be doing? In scikit-learn library, there is a Python library called scikit-learn which has got most of the algorithms present, and we will be importing this k-means clustering algorithm. And for this k-means clustering, I'm providing the c is equal to number of clusters is equal to 5. So here, if you are aware of object-oriented programming using Python, you'll be able to correlate. I'm importing this k-means clustering, which is implemented as a class here, where I'm creating an object called k-means clustering by providing an input called n number of scores clusters is equal to 5, which means that what is the meaning of 5? I want to build 5 clusters out of this. So where once you create an object using k-means, I'm calling this method called fit method by providing new data as my independent variables. I'm calling this fit method, which means fit is a method that's going to invoke what's supposed to be the process that needs to be executed. That's going to build my clustering technique algorithm by taking number of clusters is equal to 5. So now I'm able to generate my algorithm where by looking at my model, I'll be able to extract what are the centroids that I got, final centroids, because initially you'll be taking some random centroids, but at the end you'll end up with getting a final centroid position somewhere fixed to it. That is nothing but a center point for every cluster that we got. These are the final centroids that we got. Even if I want to print what is the labels which are generated, labels is nothing but it will extract the outcome. You can see that these are the label numbers which are added here. Out of 5,000 movies, we got the labels which are added as an array, but we won't be able to see it like that. What is it I'm trying to do? I'm trying to get all the unique values present in these labels with respect to counts. Now you can see that my data is now clustered into 5 different, all the movies are clustered into 5 different clusters. As you see, cluster number 0 has got 4,700. Most of the observations are moved into cluster number 0. 104 movies went into observation number 1, 11 movies are moved into cluster number 2, and 87 movies are moved into cluster number 3, and 67 into cluster number 4. That's how the data properties are being distributed, and that's how the clustering technique has divided the data into 5 clusters. Now you can see what is that I'm trying to do. I'm trying to put this into a new data of cluster, which means whatever the labels that are generated here. This is my output column. I'm going to create this into as a new column in my new data, where I'm using this LM plot that will print whatever the column that I have called director Facebook likes versus actor Facebook likes. And I'm choosing this data is equal to new data that will help me to identify what column can be considered as hue, so that I'll be printing it in a cool warm type chart. You can see that palette type is equal to cool warm type, which will help me to identify based on the cluster that you have created. Now if I print this, you can see that pretty much every observation is now categorized into individual cluster. You can see these are the movies which are now graphical representation. This is the graphical representation that we are using to see how these movies are being segregated. I can see these movies are nothing but cluster number 0. You can see there are a few more movies which are extracted over here. This is nothing but based on the color indication. This is cluster number 3, and these movies are created as a cluster number 1, cluster number 2. These movies are something which are created as cluster number 1, and these movies are created as cluster number 4. 0, 1, this is nothing but 2, cluster number 3, cluster number 3, and cluster number 4, like this. Now you can clearly see that how the K-means clustering has came up. The movies which are made by new people with new directors, new actors are making films with new directors, or new directors are making film with new actors. These are all, you will see more number of movies will fall into this category, because you will end up with getting new people into the film industry most of the cases. A lot of movies are being made with new directors with new actors, and you can see that these movies are the clusters which are being segregated very clearly. The famous actors are making films with new directors. Very famous actors are making films with new directors, and these movies are something where very famous directors are average fame directors are making films with some new actors. You can see these movies are nothing but very famous actors are making, directors are making films with very new actors. You can see very famous directors are making films with very famous actors, like Spielberg might be making a film with Tom Cruise or something like that. So likewise, you can clearly see that where instead of, if you do this activity manually, it might take a little longer time for you to segregate each and every component, but within 5 minutes we're able to cluster this activity, right? So that's what the beauty with algorithms. You don't need to manually do this activity, where you can provide your data automatically based on the properties of the data. Your algorithm itself will build this clustering output out of the data. It's very simple to do. Okay. All right. So that's how we will be able to build a clustering technique on top of the given data. So that's what we have as part of one of the hands-on example. Okay. Thank you all. Thank you very much. Have a wonderful day ahead. All the very best. Thank you. Bye-bye.